Now students, we are going to discuss the difference between the biological neural network and artificial neural network. We are going to make a difference between these two, depends on the different criteria. So first criteria is processing. Obviously, our brain is having the number of neurons, so there is a parallel processing is there. So first difference is, or first criteria is processing, and in biological neural network, massively parallel processing is there. It is slow but superior than artificial neural network. In artificial neural network also processing is massively parallel, fast but lower than the biological neural network. What is the size of the biological neural network? It is 10 to the power 11 neurons and 10 to the power 15 interconnections are there. In artificial neural network, the size of the neural network or size of the network depends on the application for which you are going to design the ANN. Okay, so basic or minimum size requirement is 10 to the power 2 to 10 to the power 4 nodes, depends on your application. Learning, they can tolerate ambiguity. It means if while processing, if you are giving the wrong input to the program in for your brain, okay, so your brain finds out that the data given by you is of no use and not related to the problem. But when you are giving input to the artificial neural network, that input should be very precise, structured, and formatted data is required to tolerate the ambiguity or vagueness in the output. Okay, fault tolerance. Performance degrades with even partial damage. If some neurons get damaged, the performance of the biological neural network get decreased. It is capable of robust performance, hence has potential to be fault tolerant. Storage capacity. Stores the information is synapse. As we discussed, biological neural network stores the information in the synapse. Artificial neural network stores the information in the continuous memory locations. Memorizing capacity. Humans can forget, but neural networks cannot. Once fully trained, a neural network will not forget. What it means, if you want to find out the solution, which pen we want to buy, this is your problem. And for that problem, you are going to use your biological neural network. Okay, so you may use the 10 types of pens or 15 types of pen, but you never remember the performance of all types of pen. So you may forget the performance of a particular type of pen, but artificial neural network not. Okay, so this is the memorizing capacity of the biological neural network and the artificial neural network. Next is memory type. A human memory or human knowledge is volatile and may not become permanent. There are several factors why human memory is volatile, because if our brain cells are brain cells to die, and if they do, the information that is stored in that part is lost and we start to forget. But for neural network, this is not the case. Whatever a neural network learns is hard coded and becomes permanent. So human memory is or biological neurons having the volatile memory type, and the artificial neural networks have a permanent memory type. Processing capacity. In biological neural network, or humans can process first 10 processes accurate, but later human may start to make mistakes in the process. But this is not the case in case of a artificial neural network. Once a particular application or process is automated through a neural network, the results are repeatable and accurate. Okay, speed. Humans are slow in processing. Neural networks can be hardware or software, and obviously it is faster than the humans in processing the data information. Now we are going to discuss the representation of the artificial neural network. See, here these are the dendrites. As you remember, dendrites are nothing but the input nodes. Okay, so here dendrites are nothing but the input nodes. So IN1, IN2 and IN up to the N. These are the input to the artificial neural network. Next is Soma. So what is the Soma? Soma is responsible for processing of the information. So here it is the bias on which you are going to implement some functions or summation function and you are getting the output. So this is the dendrites. Dendrites are nothing but the inputs. This is the cell body. Here we make it as a bias which denotes your nucleus and you are getting the output. Okay, which are the axon terminals. In the previous video, I told you you may get the one output or you may get the number of outputs for the one program. Okay, in the next next video, we will discuss the next part, which is the neuron architecture. Thank you.